Try something. Close your eyes. Now, imagine you're underwater. You hold your breath, and for good measure, you plug your ears and pinch your nose shut. The world vanishes. There is only the feeling of pressure on your skin and the muffled beat of your own heart. How would you find food down here? How would you navigate? For you, this is a hypothetical sensory deprivation chamber. For the platypus, this is just Tuesday. When a platypus dives, it enters a self-imposed silence. It hunts completely blind, deaf, and without smell. Its entire world is perceived through its bill. But this bill is not the hard keratin beak of a duck. It's soft, pliable, and rubbery, covered in thousands of tiny pores, giving it a strange, leathery texture. It's more like a highly sensitive fingertip the size of your hand than a beak. This fleshy, flexible organ is draped over its skull, packed with more nerve endings than a human hand. So what is this living sensor looking for? Not movement, not heat, not sound. It's looking for electricity. Every time a living creature moves a muscle, its nerve cells fire, creating a tiny, measurable bioelectric field. A freshwater shrimp flicking its tail to escape, a larval insect wriggling in the mud, each of these actions broadcasts a weak electrical signature into the water. These are signals of life, completely invisible to us, but to the platypus, they are like bright flashes in the dark. The surface of the bill is covered in about 40,000 electroreceptors, arranged in a series of stripes running down its length. These are specialized mucus glands, each acting as a tiny voltmeter. The sensitivity is astounding, capable of detecting fields as weak as a few dozen microvolts per centimeter. To put that in perspective, if you connected a tiny AA battery to two wires and stuck them in opposite ends of an Olympic-sized swimming pool, a platypus could not only detect it, but point to exactly where the wires are. While hunting, the platypus doesn't just point its bill forward. It engages in a behavior called a saccadic head sweep, moving its head rapidly from side to side 2 or 3 times per second. With each sweep, the thousands of receptors build a two-dimensional electrical snapshot of the riverbed. By comparing the timing and strength of the signals arriving at different parts of the bill, its brain calculates the precise direction and distance to the source. It's not seeing, it's constructing a live 3D electrical map of its surroundings. This entire system seems bizarrely complex, but it's a perfect solution to an environmental problem. Platypuses live in slow-moving, often murky, freshwater rivers and streams. In this environment, visibility is frequently zero. Sight is a useless sense here. Relying on vision would mean starving. Electroreception allows the platypus to exploit a niche that is inaccessible to other predators who hunt by sight. It doesn't just survive in the murk, it owns it. This sixth sense isn't a new evolutionary gadget. It's ancient. Platypuses are monotremes, a lineage of mammals that diverged from our own over 166 million years ago. They still lay eggs. And this electric sense is a primitive trait, something their distant reptile-like ancestors may have possessed. While most mammals evolved to dominate on land, losing this aquatic sense, the monotremes held onto it. The echidna, the platypus's only living relative, also has electroreceptors on its snout, though far fewer, using them to find termites in damp soil. It's a ghost of a sense from a different world. The raw data from 40,000 receptors is useless without a brain to process it. A massive portion of the platypus's neocortex is dedicated to interpreting signals from the bill. If you were to map the platypus brain based on sensory importance, you'd get a bizarre, distorted creature. This is its sensory homunculus, a platypus with tiny eyes, small limbs, a small body, and an absolutely enormous, flattened bill that dominates its entire being. Its reality is filtered through this single, extraordinary organ. But the system is even more clever. The bill doesn't just have electroreceptors. Interspersed among them are 60,000 mechanoreceptors, which detect pressure and water movement. So as the platypus sweeps its head, it's receiving two sets of data simultaneously, an electric map and a motion map. The electric field says, prey is here. The pressure wave says, it's moving this way. The brain fuses these two streams of information, creating a perception of its target that is far more accurate and detailed than either sense could provide alone. Our world is defined by what we can see, hear, and touch. We live in a reality dictated by photons striking our retinas and air vibrations hitting our eardrums. It feels complete, but it isn't. The platypus experiences a fundamental force of the universe as a primary sense. It navigates a landscape of silent, invisible electricity. It reminds us that our perception of reality is not the whole picture. It's just one version, tuned to one set of channels. What other realities are all around us, unseen, unfelt, and completely unknown?
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.